Hi, and welcome to my video on derivative product rule number 4. In this video, I shall do a few examples of the product rule. Number 1, the P of x equals sine x cos x. Find the value of P prime of pi over 6. Well, first of all, pi over 6, pi is equivalent to 180 degrees. So that's the same as 30 degrees. So that's P prime of 30 degrees. I look at degrees instead of radians. And P prime is the derivative. So let's say this is F and this is G. So P prime is the derivative of a product. So that's F prime times G plus F times G prime. So F, that's the sine of x times cos x, plus F, which is sine x, times the cos of x and derivative. So the derivative of sine is cos x times cos x. And this is sine x. Derivative of cos x is negative sine x. So when you multiply, that's cos squared x, and positive times a negative is a negative, and that's sine squared x. So we want to find the prime of 30 degrees. So if we want to find the sine of 30 degrees, let's draw a circle, and let's draw the unit circle with a radius of 1, and we do a rotation up along here of 30 degrees, which is equivalent to pi over 6. We drop a terminal arm to the origin of 0, 0. We drop a perpendicular to the x-axis. Since this rotation is 30, this reference angle is 30, so this is a 60, that's a 90. It's a unit circle, so the hypotenuse is 1. Opposite 30 is a half. Opposite 60 is root 3 over 2. So the cos of x, the cos is the adjacent over the hypotenuse, so it's root 3 over 2. And the sine of 30 is opposite of our hypotenuse. Notice the hypotenuse is 1, so it's 1/2 being squared. So root 3 over 2 squared, root 3 times root 3 is 3, 2 times 2 is 4. 1/2 squared, 1 times 1 is 1, 2 times 2 is 4. So that gives us, common denominator is 4, so 3 minus 1 is 2. So that works out to be 1/2. So that's an example of using the product rule when you do the derivative. And let's do another question. Find the angle, find the angle. Find the equation of the tangent to h of x at x equals 1. So the equation of the tangent is related, or we say, to get the equation of the tangent, we have to find the slope. The slope at point is the derivative of this function. So what we can do is we can do the derivative, but this is the f and this is the g again, and h prime x is f prime times g plus f times g prime, and again the prime is the derivative. So let's write the first one down, which is x cubed minus 4x squared plus 1, derivative, and this is times g, which is 2x squared minus 3x, add on f, which is right here, write that down, x cubed minus 4x squared plus 1, and we have the derivative of g, so 2x squared. I could have did the derivative without writing this down, but I wanted to show you that it's derivative of f times g and plus f times the derivative of g. So the derivative of f is 3x squared minus 8x, and the derivative of a constant is 0. So that's 2x squared minus 3x. And we write down this trinomial. There it is. And the derivative of 2x squared, 2 times 2 is 4, the x, derivative of linear is negative 3. So I could multiply all this out, but I want to find the derivative, which is the slope of the tangent when x is 1. So it's very easy. I'm going to put 1 in the place of x, but rather than plug it in, and I'm going to put 1 in the place of x. So if I put 1 here, 1 squared is 1, so that's a 3. Put a 1 here, negative 8 times 1 is negative 8. Put a 1 here, 1 squared is 1, so that's a 2. Negative 3 times 1 is negative 3. Put a 1 here, 1 cubed is 1. And again, putting a 1 in is not going to change the numbers. Just think about it. Putting a 1 in, you get a 4 and a 3. When you put a 1 in, the coefficients or the numbers that I have there stays, not going to change. So this is negative 5, negative 1, plus this is negative 2, and this is 1. Notice I worked the inside the brackets first by PEMDAS. Now I have to multiply before I add, so that's a 5, and that's a negative 2. So when I multiply, I get 5. When I multiply here, I get negative 2. So that's a 3. So the derivative at 1 is 3, so that means the slope of the tangent is 3. So what is the point at 1? So we do the h. So now we're going to put, this is h is x cubed minus 4x squared plus 1, and 2x squared minus 3x. So again, I'm going to do the h of 1 and find what the what the x value is, what the h of 1 is. So again, we could put 1 in here, but if you put 1 in, you get the 1 coefficient. You put a 1 in here, you get a negative 4, and that's plus 1. You put a 1 here, you get a 2. You put a 1 here, you get negative 3. Simplify, and I get a negative 2. And simplify here, I get a negative 1. And we multiply, we get 2. So that point, that lies on the h of f, when x is 1, y is 2. So we have the slope is equal to 3. And now the equation is y equals mx plus b, and slope y-intercept 4. So this is x, and this is y, and that's a 3. So y is 2, m is 3, x is 1, so we find the b. So 2 equals 3 plus b. So b equals 2 minus 3. So b equals negative 1. So the equation y equals mx plus b, which is the equation of the tangent. So the slope is 3, and the y-intercept is negative 1. So again, I'm using the derivative, which is the slope of the tangent, but I'm using the product rule, and I made it easier by plugging the 1 in. So I didn't have to multiply all this out and simplify it. I just had to put the 1 in to get what the slope of the tangent is. A quick way of doing it. And if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.